Atmospheric pressure is the force per unit area exerted on a surface by the weight of air above that surface in the atmosphere of Earth. In most circumstances, atmospheric pressure is closely approximated by the hydrostatic pressure caused by the weight of air above the measurement point. On a given plane, low-pressure areas have less atmospheric mass above their location, whereas high-pressure areas have more atmospheric mass above their location. Likewise, as elevation increases, there is less overlying atmospheric mass, so that atmospheric pressure decreases with increasing elevation. On average, a column of air 1 square centimeter in cross-section, measured from sea level to the top of the atmosphere, has a mass of about 1.03 kg and weight of about 10.10 n. Standard atmospheric pressure. The standard atmosphere is a unit of pressure equal to 101,325 pascals or 1,013.25 millibars or hectopascals. It is equivalent to 760 mHg, 29.92 in Hg, 14.696 psi. SI system, the Pascal unit is derived from Newton per meter squared. However, the Newton is derived from kilogram meter per second squared. Hence, by the use of base SI units only, the value of standard atmospheric pressure equals 101,325 kg/s2m, kilogram per meter per second squared. When physicists use math, it's usually written as 101,325 m-1 kg s2. Mean sea level pressure. The mean sea level pressure is the atmospheric pressure at sea level or the station pressure adjusted to sea level assuming that the temperature falls at a lapse rate of 6.5 K per km in the fictive layer of air between the station and sea level. This is the atmospheric pressure normally given in weather reports on radio, television, and newspapers or on the Internet. When barometers in the home are set to match the local weather reports, they measure pressure adjusted to sea level, not the actual local atmospheric pressure. The adjustment to sea level means that the normal range of fluctuations in atmospheric pressure is the same for everyone. The pressures that are considered high pressure or low pressure do not depend on geographical location. This makes isobars on a weather map meaningful and useful tools. The altimeter setting in aviation, set to either QNH or QFE setting, is another atmospheric pressure adjustment, but the methods of making these adjustments are different. QNH is the barometric altimeter setting that causes an altimeter to read airfield elevation when on the airfield. In ISA temperature conditions, the altimeter will read altitude above mean sea level in the vicinity of the airfield. QFE is the barometric altimeter setting that causes an altimeter to read zero when at the reference datum of a particular airfield. In ISA temperature conditions, the altimeter will read height above the airfield runway threshold in the vicinity of the airfield. QFE and QNH are arbitrary Q codes rather than abbreviations, but the mnemonics nautical height and field elevation are often used by pilots to distinguish them. Average sea level pressure is 101.325 kilopascals or 29.92 inches or 760 millimeters of mercury. In aviation weather reports, QNH is transmitted around the world in millibars or hectopascals, except in the United States, Canada, and Colombia where it is reported in inches of mercury. In the weather code, 3 digits are all that is needed. Decimal points and the 1 or 2 most significant digits are omitted. 1013.2 millibars or 101.32 kilopascals is transmitted as 132. 1000.0 millibars or 100.00 kilopascals is transmitted as 000. 998.7 millibars or 99.87 kilopascals is transmitted as 987. Etc. The highest sea level pressure on Earth occurs in Siberia, where the Siberian high often attains a sea level pressure above 1050.0 millibars, with record highs close to 1085.0 millibars. The lowest measurable sea level pressure is found at the centers of tropical cyclones and tornadoes, with a record low of 870 millibars. Altitude atmospheric pressure variation. Pressure varies smoothly from the Earth's surface to the top of the mesosphere. Although the pressure changes with the weather, NASA has averaged the conditions for all parts of the Earth year-round. As altitude increases, atmospheric pressure decreases. One can calculate the atmospheric pressure at a given altitude. Temperature and humidity also affect the atmospheric pressure, and it is necessary to know these to compute an accurate figure. The graph at right was developed for a temperature of 15 degrees Celsius and a relative humidity of 0%. At low altitudes above the sea level, the pressure decreases by about 1.2 kPa for every 100 meters. For higher altitudes within the troposphere, the following equation relates atmospheric pressure P to altitude h, where the constant parameters are as described below. Local atmospheric pressure variation. Atmospheric pressure varies widely on Earth, and these changes are important in studying weather and climate. See pressure system for the effects of air pressure variations on weather. Atmospheric pressure shows a diurnal or semi-diurnal cycle caused by global atmospheric tides. This effect is strongest in tropical zones, with amplitude of a few millibars, and almost zero in polar areas. These variations have two superimposed cycles, a circadian cycle and semi-circadian cycle. Atmospheric pressure records. The highest adjusted to sea level barometric pressure ever recorded on Earth was 1085.7 hectopascals measured in Sincanjal, Mongolia on December 19, 2001. The highest adjusted to sea level barometric pressure ever recorded was at Agata, Aveniysky, Russia, 66 degree 53 euro unregistered trademark N, 93 degree 28 euro unregistered trademark E, elevation, 261 am, on December 31, 1968 of 1083.3 hectopascals. The discrimination is due to the problematic assumptions associated with reduction of sea level from high elevations. The lowest non-tornadic atmospheric pressure ever measured was 870 hectopascals, set on October 12, 1979, during Typhoon Tip in the western Pacific Ocean. The measurement was based on an instrumental observation made from a reconnaissance aircraft. The normal high barometric pressure at the Dead Sea, as measured by a standard mercury manometer and blood gas analyzer, was found to be 799 mHg. Atmospheric pressure based on depth of water. Atmospheric pressure is often measured with a mercury barometer, and a height of 760 mm of mercury is often used to illustrate atmospheric pressure. However, since mercury is not a familiar substance to most people, water may provide a more intuitive way to visualize the pressure of one atmosphere. One atmosphere is the pressure caused by the weight of a column of fresh water of approximately 10.3 m. Thus, a diver 10.3 am underwater experiences a pressure of about 2 atmospheres. This is the maximum height to which a column of water can be drawn up by suction at atmospheric pressure. Low pressures such as natural gas lines are sometimes specified in inches of water, typically written as WC or WG. A typical gas using residential appliances rated for a maximum of 40 in a WC, which is approximately 35 hectopascals. In general, non-professional barometers are aneroid barometers or strain gauge based. See pressure measurement for a description of barometers. Boiling point of water. Clean fresh water boils at about 100 degrees Celsius at Earth's standard atmospheric pressure. The boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure around the water. Because of this, the boiling point of water is lower at lower pressure and higher at higher pressure. This is why cooking at elevations more than 1,100 am above sea level requires adjustments to recipes. A rough approximation of elevation can be obtained by measuring the temperature at which water boils. In the mid-19th century, this method was used by explorers. Atmospheric pressure measurement and maps. An important application of the knowledge that atmospheric pressure varies directly with altitude and the availability of reliable pressure measurement devices was in determining the height of hills and mountains. While in 1774 Maskelyne was confirming Newton's theory of gravitation at and on Hellion in Scotland and accurately measure elevation, William Roy using barometric pressure was able to confirm his height determinations, the agreement being to within 1 meter. This was then a useful tool for survey work and map making and long has continued to be useful. It was part of the application of science, which gave practical people the insight that applied science could easily and relatively cheaply be useful. See also: high pressure area, low pressure area, atmosphere, barometric formula, barotrauma, physical damage to body tissues caused by a difference in pressure between an airspace inside or beside the body and the surrounding gas or liquid. International Standard Atmosphere, a tabulation of typical variation of principal thermodynamic variables of the atmosphere with altitude, at middle latitudes. NRLMSISEOO, plenum chamber, subtropical high belts, cabin pressurization, references. External links: How atmospheric pressure affects objects, NASA page on the 1976 Standard Atmosphere, source code and equations for the 1976 Standard Atmosphere, a mathematical model of the 1976 U.S. Standard Atmosphere, calculator using multiple units and properties for the 1976 Standard Atmosphere, calculator giving standard air pressure at a specified altitude, or altitude at which a pressure would be standard, some of the effects of air pressure, atmospheric calculator and geometric to pressure altitude converter, experiments, movies on atmospheric pressure experiments from Georgia State University's hyperphysics website. Euro requires quick time, test showing a can being crushed after boiling water inside it, then moving it into a tub of ice-cold water.